सर रिकॉर्डिंग शुरू किया है क्या? ओके। सुप्रिया मैम,
हाँ यस मैम।
आपका सेकेंड सेशन है ना मैम?
हाँ मेरा सेकंड सेशन है, अभी शुभदा मैम करेगी।
ओके सर, मैम का भी आवाज आ रहा है ना अच्छे से?
हेलो।
हाँ मैम, मुझे तो आवाज आ रहा है।
आवाज हाँ आ रहा है ना?
हाँ।
ओके ओके ओके।
ओके।
हेलो।
शुभदा मैम,
हाँ मैम ऑडिबल। हेलो। हेलो।
हेलो।
हाँ मैम
हाँ मैम, आवाज
ऑडिबल।
आ रही है मैम। हाँ,
ओके।
ऑडिबल है, ऑडिबल। हाँ।
Hello, sir, I'm audible.
Yes, you are audible.
Can we wait for 2 more minutes? Okay, sir. Okay, thank you. Sir, can we start?
Yes, we can start.
Okay, sir. Thank you. Good evening, all. Welcome to the day 5 of ATAL Online Faculty Development Program. It is with great pleasure that we introduce Mr. Sanjay Raghunath Bagul, sir, a distinguished professional in the field of civil engineering with a specialization in civil water management. He brings with him from SGGS Government College of Engineering in 1997 and his ME from College of Engineering in 2000. Professionally, he has served as manager with Electro Steel Casting Limited and also as a public health engineer in Directorate of Construction Services and Estate Management in 2005. Currently, he holds the position of scientific officer. He was involved in designing and implementation of water supply network for more than 25 cities. His work encompasses a wide range of public health engineering projects, including sewage system, stormwater drainage, underground and overhead water tanks, rainwater harvesting schemes, and many more. Beyond his technical contribution, Sir has been active member of engineering community. He is a former honorary secretary of Institution of Engineers and affiliated with numerous professional bodies such as IEI, IWWA, ISRS, and many more. He serves as an external examiner for UG and PG students for their dissertation, showcasing his commitment to education. With his rich expertise and outstanding contribution to the profession, we are delighted to welcome Mr. Sanjay Bagul, sir, to address us today. Welcome, sir. Over to you.
Good evening, Mr. Bagul.
Namaste, sir.
Namaste. How are you? Fine.
Fine, sir.
Yes, sir. Please continue. Please continue.
Okay.
I'll be there.
Thank you, Tandon, sir. Thank you, Shubhada, madam, for very big introduction. Today is a Teachers' Day. I wish very grand Teachers' Day to everyone. I will
Happy
share
Teachers'
my...
Day to you too, sir.
Thank you, sir. I will share my screen. The screen is visible, madam?
Yes, sir. Yes, screen is visible, sir.
Yes. Okay. I'm not going to present any case study today. We will discuss the techniques available for rainwater harvesting and some easily available equipments in the market. Rainwater harvesting is not new to India. For us, it is an ancient technique which is to be implemented in this new age. All may have attended yesterday's solid waste management lecture by Dr. Dagaonkar. I am having the same opinion as he is having, that simple technology gives better result and are easy to maintain. Choice of rainwater harvesting technology shall be based on location, technical infrastructure available, then requirement of user and requirement of statutory bodies. Like in Bombay Municipal Corporation, Brihan Mumbai Municipal Corporation, if your plot is more than 50 square meter, rainwater harvesting is compulsory. Similarly, in SIDCO, I have seen that for 40 meter squares plot also they are asking rainwater harvesting. In this presentation or discussion, we will see that what is rainwater harvesting, then history of rainwater harvesting, use of rainwater harvesting techniques, rainwater harvesting components and available techniques for that components, and at the last, design of rainwater harvesting. So we will start with what is rainwater harvesting. So many things I have already written, so that sometime you will see that or feel that I am reading, but I have compiled it for you to make it available. It doesn't need that what I have saying you have to remember it. It is visually also available. So many videos are also available in this presentation, which are collected from the uh, net or product suppliers. But this is orientation is what techniques are available. You can understand these techniques and implement them. It doesn't mean this is a advertisement of any agency. What is rainwater harvesting? It means capturing rain where it falls or capturing the rain runoff in your own compound, village, or town, and taking measures to keep the water clean by not allowing polluting activities to take place in the catchment area. The sources from which these definitions and another things are made available are also stated at the bottom of my slides. Rainwater harvesting can be undertaken through various ways. One is capturing runoff from rooftops, capturing runoff from local catchments, capturing seasonal flood water from local streams, conserving water through watershed managements. These techniques can serve the following purposes: providing drinking or flushing water, providing irrigation water, increase groundwater recharge, reduce stormwater discharge, urban flood, and overloading of sewage treatment plants is also avoided through this. Reduce seawater ingress in the coastal areas, reducing soil erosion as surface runoff reduction, improve groundwater quality, decreases salinity by dilution, increase in groundwater table, reducing energy consumptions by reducing the pumping lift. As the groundwater table increases, our pumping lift reduces, and it also indirectly reduces our uh, electricity bill. Uh, Subsurface aquifer reserves as stores and water distribution system, reducing capital cost. So the subsurface infrastructure of our earth can be utilized as a distribution system. So everyone who is requiring water can make a well and extract the water. If we think in this way, the distribution network cost is saved. All these things we are looking in the scenario of a smart city. The smart city, when we are planning, there is uh, municipal corporation or the uh, persons who are keeping this city that necessary to provide source of water. So for a city, rainwater harvesting can be a dam. For a person, it can be a collecting from roof and uh, saving the water for himself. In general, rainwater harvesting is the activity of direct collection of rainwater. The rainwater collection can be stored for direct use or can be recharged into the groundwater. Rain is the first form of water known in the hydrological cycle. Hence is a preliminary source of uh, water for us. Rivers, lakes, groundwater are all secondary sources. In present time, we are dependent on these secondary sources. In the process, we have forgotten that rainwater is the ultimate source that feeds all the secondary sources. So, for creating such secondary sources, the more money will be required, like dam on river and other things. It needs more money. If everyone collects his own water at his house, these dams and other infrastructures will not be required. uh, Rainwater harvesting means to understand the value of rain and to make optimized use of the rainwater at the place where it is fall. So जहाँ पे गिर रहा है वहीं पे use करो. The basic principle is catch water where it falls. Rainwater harvesting. Now we will see the history of rainwater harvesting. Uh, for India, it is a ancient technology. Civilization in Indus valleys were far more advanced than we may think nowadays. So many structures has found there that they were having a very good water collection system, water circulation system, and very good drainage system. Even one document I have seen that it shows that uh, European water closet design is not actually designed by them. It has been found in some old Indian civilizations. In many of the ancient cities that still remain, we can still find huge walls that were cut into the rocks to collect water when there was a torrential sheer rainfall. These were used to keep the population and local vegetation going in hotter and dry time, and were fed by numerous stone gullies that were waved their ways through the city. Some of these rock walls are still used today in part of India. Another technique that has been used for hundreds of years is in India is to build water harvesting system on top of the roof of house. The technology of rainwater harvesting is deeply rooted in the social fabric of India, with a variety of ancient methods still found today, like uh, talabs, uh, johads, bauris, jalaras. These are now also are in use. For us to visualize, the easy way is to see the developments which are the ancient developments or historical developments which are not used as present and can show us the water collecting structures. For that, I have taken some pictures from the forts of Maharashtra. So they are used around 600 to 400 years before, and for at that time the water collection system was only the rainwater harvesting. We can see these photos. This is one fort called Janjira, which is surrounded by a sea, Arabian Sea. But we can see the water collecting structures at the center. These are totally man-made structures around 400 to 600 years before. Similarly, in the Vijay Durg, we can see that the square water holding structure is created, which has a placed at the lowermost slope and is collecting the water. Uh, these two images are from the Google. Of one is of Raigad fort and another is Pratapgarh forts. In this, we can see at Raigad Fort, one Bandara has been created and one Gangasagar lake has been created. Likewise, here Kushawat lake has been likewise nearly 7 to 8 uh, rainwater harvesting structures are there. All are placed in well manner that we can see the slope of the ground and another things which are supporting the collection. Similarly, in Pratapgarh Fort, we can see talab, one tank has been constructed at the junction, and even at the corner of cliff, one uh, water holding structure has been designed, and it is at present available there. Sorry. Now we will see the region wise what are the different rainwater harvesting structures are available. We will see that in Rajasthan and Gujarat, jalaras are presently available, which are the ancient one, specially constructed tanks that are used for the local communities. Then in Bundelkhand and Udaipur, talabs, also called as bandi, medium to large size reservoirs that provide irrigation to localized plantation as well as drinking water. Then in Rajasthan, bauris are available, wells dug into the ground that are often still used for the drinking water. Then in Rajasthan, individual houses are having tankas built in as a cylindrical paved underground pit, which is filled by rainwater received from the rooftop and courtyard. This is a totally man-made catchment area is used. Then in South Bihar, Ahar pines are the reservoirs which are created by the embankment on three sides, built at the end of the diversion canals for the harvesting flood water. When floods comes, the water is collected in these trenches, and it is used after flood time for irrigation. Similarly, in Alwar district of Rajasthan, we can find johads, a naturally occurring three-side high elevational regions were excavated for building earthen storage pit called as johads, and were oldest system that were built to conserve and recharge ground. Similarly, these are the Jaisalmer and Rajasthan khadims are created. Khadims are the basically long earthen embankment that was built across the hill slope of gravelly uplands where sluice channels and spillways allow the excess water to drain off. The land with saturated water then afterward is used for the crop production. In this process, due to the silting, also the gravelly sand is getting converted into the agricultural land. In Tamil Nadu, ERIs are the tanks system which is used to control the floods. During the floods, the water is collected in this tank, which is having the central approach from where one can extract the water from the central part of these tanks. Then in Rajasthan, kunds are there. These are the saucer-shaped catchment area that has a gentle slope towards the central circular underground well. It also acts as a catchment and also acts as a tank, and also it is having at the central location a well. So it serves a total catchment purpose also and storage purpose also. Similarly, in Gujarat, Rajasthan, Delhi, and Karnataka, Bauris are there. Uh, these are the another type of step wells structure beautifully carved in arches, carves, motifs, and at the same some places rooms are also made available around at the sides of these wells. Due to the well, the area around this is cool, and it is also used for resting. In some villages, this is also used as a gathering place. Then there is a Nadi. In Jodhpur area, this is basically what we say uh, pond, a pond owned by the village. So this is a pond owned by the village with its own catchment area. Then in the Maharashtra area, Dhule and Nasik, Bandhara Fad is used. A Bandhara Fad is the most popular method of water conservation, which involves building a Bandhara check dam across a river. The canals branches out from these Bandharas will water and take them to the fields in the FUD. The FUD is basically a one agricultural block. In the region of Ladakh, zincs are present. In this region, the water is collected from the glaciers. From these glaciers, it is diverted to the lakes, and from lakes, this glacier water is used for agriculture or another purposes. Similarly, in Himachal Pradesh, the khools are there. These are the basically channels which conveys water of glaciers from the mountains to the habitats. In northeast area, Nagaland, Zabos is a practice observed in forested hilltops areas like while doing the artificial forestations, they also develop the contour bunding and store the water. In this water, they used to feed their cattle, and cattle use this water for day-to-day resting and other things, making this water fertile, rich, and indirectly improving the soil quality. Then there are parts used in the Madhya Pradesh. The part system is efficiently used to divert water from hilly streams into the irrigation channels. The groundwater recharge and rainwater harvesting techniques are need more in the recent era than the ancient time. It is due to the increasing population and global warming, which is adversely affecting the demand supply cycle of water for natural sources. Now we can see how we can use the rainwater. Rainwater is the purest form of water available on earth. It gets contaminated during its travel through atmosphere. Even some bacteria are also seen that which are present in the atmosphere are get in the rainwater and comes to the earth. And on the surface, it is polluted by the flowing through over the land. It is soft, low in salt content, and low in impurities. Rainwater can be directly used for gardening, car washing, washing clothes, floors, bathing, toilet flushing, firefighting, etc., but not for the potable purpose. After due disinfection and required filtration, rainwater can be used for potable purpose. So directly consuming rainwater for intake, human intake, is not recommended. It should be first disinfected and then utilized. Rainwater harvesting techniques. One is storing water, rainwater for ready use in underground tanks, ponds, check dams, etc. Another technique is recharging the aquifers below ground through recharging pits, recharge uh, trenches, recharge wells, recharge shafts, lateral shafts with bore well, spreading techniques, etc. Using soil strata as storage media, which is made available by the nature free of cost. Rainwater harvesting system components. So every system is having a series of components. Irrespective of the complexities, rainwater harvesting system will have the following 5 or 6 basic components. One is catchment, the surface from which rainwater is collected for storage. This could be a rooftop, paved flooring, surface, or a landscape area. Catchment area is the area of the surface usually calculated in the square meters. Gutters and downtake pipes leads the water from the catchment surface to the storage tank. Basically, this is a conveying system. Filters and flush device. Filters are used for removing grit, leaves, and dirt that the rainwater may transport from the catchment before water enters the storage tank. A first flush device diverts the water from the first rain so that it does not enters in the storage tank. Whenever first rain comes, it wash out the all impurities, and that washout water should not be collected. It will have the maximum contamination. Then the storage tanks. These are this can be above the ground or below the ground. Then from tanks, delivery system of piping is required to utilize rainwater. And the last one is whatever the rainwater which you don't want to use, you can directly recharge groundwater. There are many artificial recharge systems available for use, and also we are having a one IS code for artificial recharge systems. So in pictorial presentation, we can see that there is a catchment, then gutter, downtake pipe, then storage at the elevated location, delivery pipes, then first flush system is there. Then there is a one filter on the ground, and this water is collected in the underground structure. Here recharge structure has not been shown. So we will see one by one. The catchment is any surface from which rainfall will be collected. Depending upon the type of surface runoff, rainwater potential will change. If the hard surface is there, more rain can be collected. If it is a grassy land, the percolation will be more and less water will be available. Considering that these are all the roofs, gutter and downtake systems will be required. These systems is required to take care of maximum hourly rainfall, which is normally called as a design rainfall. Filters and first flush devices. These are mainly two types of filters used before storing of rainwater or injection recharge. One is online filters. There are also screen filters available, which are installed directly on the rainwater pipe downtakes. And then gravity filters, sand filters are also used. We can see the what type of online filter which are available in the market. The rain down take is connected to the filter, and when first time rain comes, this tap is opened so that this is directly thrown away, and afterwards the water rises, filtering through the filter and is stored in the underground storage. The main disadvantage in this type of filter is that when the rainwater stops, the water in this much area is maintained in the pipe, and if there is a very long period, then this water is get contaminated, and it should be uh, thrown by manual intervention. These are also the type of online filters. Water enters from one end. There is a sieve on the center portion. Due to the sieve, the water is dropped down and collected in the underground tank, and whatever maybe the dirt is pushed in front due to the flow of water. Similarly, in this case, filter surface is used to filter water on pipes. This is the one of the technology I found very promising. This is a rainy filter. It is a patented one. Rainy filters are designed with self-cleaning mechanism and can be fixed to the wall by connecting rooftop rainwater drain pipes. Basically in this case, the water is coming from this side. Here it is get filtered by centrifugal force, and the dirt is directly dropped down, and due to the centrifugal force, water enter in this area and flows towards the your storage. The sieve provided here is of the SS. We can see details of this filter in next slide. The best thing will be we will see it in the functioning. So water enters here, moves around this, then comes down, and having the same force, it passes through this sieve, and whatever the leaves and another things are there, they can't pass through this sieve, so they get dropped down. We can see the animation for this filter. 1 minute.
The downtake pipes from the roof has to be interconnected and lead till the filter unit and has to be connected to the inlet of the rainy filter. The rainwater, along with dirt and debris, flows by gravity through the pipeline, enters into the filter, starts rotating in anti-clockwise direction at the periphery of the upper housing so as to flow into the SS304 filter element placed in the lower housing in angular motion at specific velocity, which creates cohesive force at low intensity and centrifugal force during high intensity of rainfall, which aids the filter element to flush out automatically the dirt and debris through the drain outlet and simultaneously divert clean water into the sump or recharging well through the clean water outlet.
During the first flood, this tap is kept closed so that all water coming here goes to the drain. We can see the actual working here. So in this case, for cleaning of dirt, or even in the first flush, very less manual efforts are required. The next one is these are the online filters, and next is the gravity filter. We all, as a civil engineer, know what is the filter. It is basically container filled with a different type of filters, and water filters through it. The velocity of flow in this filter is very less, but this is the one of the most promising quality giving filter arrangement. The next component is storage. Storage will be in normally is a underground tank or a overhead tank made from the concrete, brick, ferroconcrete, polyethylene, or FRP. And there are also now available modular underground tanks. This is one of the new concept comparatively, even though 10 to 12 years old. In this, boxes are created, mesh boxes of plastics are created from the recycled plastic or virgin plastic, which are the mainly supporting elements. The rain which is coming from the roof is basically desilted and filtered and collected in these underground boxes, which are lined with a geotext and liner, which does not allow the water to come out. So indirectly this acts as a tank, and even from the top surface only geotext has been provided, so whatever water get filters through the soil can be collected in these boxes. One opening is provided which supports extraction of water from these boxes as just like a bore well. The overflow of these boxes goes to the another unit which is having a perforated boxes and a bore well unit, where this box are only geotext are lined with only geotext, which allows percolation from the boxes to the soil also and to the bore well also. And in this case, the upper area can be used as a garden or a parking area. Only the restriction for this is whenever you are using it for parking, you should make sure that your boxes are capable of taking the load. The installation steps for these are shown here. First, the bore wells are made, then the excavation for the trench is made, base is filled with sand for giving a bottom support, then geotext is spread, over which the required boxes are installed. Then geotext is totally wrapped. If you want it to percolate, then final layer is not used, means impermeable layer is not used. If you want it as a storage tank, then impermeable layer is used, and over that you can see the area is used for movements, garden, parking, lawns, in many fashions. We can see one video here showing how these systems can be installed. First, the bore well is made. This is the base preparation for geotext. The number of supports provided in this are dependent on the how much loading capacity you need. This is used for only percolation. Then filter gate geotext is used. If you want to use it as a tank, then liner is used. Impermeable liner is used. So we can see that garden has been developed over the storage. We are also having some more videos which give more details about.
Hey, Ed Ballou here, part of the Aquascape Pond Squad and also known as the Conservation Guy. Today, I'm going to show you how to capture, filter, and reuse rainwater using the Aquascape rain exchange system. There are two main reasons to capture rainwater. The first and most obvious is water conservation. It is estimated that at least 36 states expect to face water shortages within the next 5 years. So water conservation isn't just for those that live in the arid Southwest. The second reason is to use the rain exchange system as a solution for managing stormwater runoff and prevent flooding on properties. If you live in a region that receives heavy rainfall and has issues with flooding, the rain exchange just might be the solution to your problems. One of the easiest ways to capture rainwater is using the Aquascape downspout filter. It's located at the base of a downspout, and it has a 300 micron mesh bag located inside of it. It's made for easy removal. This is going to capture all the leaves, twigs, debris, and sediment that's generated from the roof. From here, the water goes through a pipe system into our underground modular reservoir. The revolutionary design of the rain exchange system combines our modular underground reservoir with a decorative water feature. The benefit of that is you get the sight and sounds of the water feature combined with the aeration and the filtration aspects of the moving water, giving you better, more usable water. Beneath me is a 1,000-gallon reservoir. We're capturing all the water off the backside of the home. The water gets routed into our modular underground reservoir. From here, it gets recirculated into our decorative water feature. This creates a truly sustainable water feature using all rainwater. The underground reservoir is comprised of the AquaBlock storage units. These are made from recycled plastic, and the modular nature of these units allow you to put them together in a variety of configurations to meet the site requirements for any size project. The other nice thing about this system is it's designed for H20 loading. That means you can drive heavy equipment and vehicles over the top of the system once it's buried and backfilled. This is perfect for commercial applications. Aquascape's patented snorkel vault houses a high-efficiency pumping system and provides a convenient access point for inspection and maintenance. An alternative method for capturing rainwater is through the use of permeable pavement. This is a specially designed brick that has joints built into it. These joints allow the rainwater to flow down through those joints. Underneath this permeable pavement system is a rubber lining, which actually stores 1,500 gallons of water in our rain exchange system. Once we have that water captured, filtered, and stored, it's perfect for irrigating our landscape or a variety of other outdoor uses. The rain exchange comes in prepackaged, easy-to-use kits, and it can also be customized for larger or more unique projects. For more information on the rain exchange,
Here the installation of boxes is in detail.
Hi, my name is Randy Cobb, 100-gallon modular underground tank system. Triple modules, and each triple module handles about 91 gallons of water. So we're going to be putting 28 of these in the tank, and all in all, we're going to come.
Sorry. Hello.
Yes, sir.
I think it has been hanged. Wait for a while.
Okay, sir. Okay, no problem. No problem, sir.
Yeah. Screen is visible?
Yes, the screen is visible.
Okay.
Gravel base down there. They've actually compacted and smoothed it out so that we've got our tolerances right for the bottom of the product. A second layer of geotech is placed in the bottom of the hole between the liner and the tank modules for added protection. I've got a model here to help demonstrate how we're going to wrap the tank system up with the liner in order to keep things watertight. First, we've excavated our hole, and we've laid down a layer of geotextile fabric that helps protect the liner from the soil that's below it and on the backfill on the sides. And then once we've got the liner installed, we're laying a small piece of geotextile down at the bottom of the hole in order to protect the liner from the installed tanks. We install our tanks down into the hole, we center it up on that geotech, and then we begin to wrap it. And what we're going to do is start by folding the long direction up over the sides of the tank. We're going to pull it up like this until it's tight, and then we're just going to take tape. In your case, it's going to be duct tape. And you just tape it to the top of the tank. Do the same thing with the opposite side, pulling it in. One of the important things about this is trying to keep these wrinkles out of it. You'll see why later on, but in order to keep it watertight, we have to keep these wrinkles out. When you do the ends, all that's really necessary is to get your
This
poles
part
pretty
is
close,
more important
pull them up over the tank.
for using a
But
cloth.
what's important is that when we fold this, if we fold it up like a present and just wrap it up like this and pull it up,
will leak.
what happens is water is going to leak out at these low spots. We're going to end up having a leaky tank. Can't have that. So what we're going to do is we're going to fold it up best we can, pull it up on top of the tank like this, and then we're going to reach inside and we're going to pull all of this excess material up on top of the tank. And once we've got it all nicely folded and all that slack taken out, you can actually go back and cut some of the material off the top, try and get rid of it, make it easier to work with. But for now, we're going to secure that in place we're going to do the same thing on this other corner over here, pulling the material back up inside. Now, obviously, this is a model. In real life, this is going to take some time because you're talking about some very heavy liner material and a very large box. So now that we have it folded up in place, what we're going to do is we're going to use some adhesive. And the adhesive you're going to get is going to be used on top of this edge, on top of this edge, here on top of the liners. You'll let it dry for about a minute or so, and you'll lay it back over here and seal it. Of course, you'll seal all these edges around here with that adhesive cement, and you're going to do the same on both sides. Once this side is good and secure and sealed up, then we're going to go ahead and do the same exact thing on this other side. Fold it back over, seal the edges here, and seal along this final stop, the strip up here to complete your complete tank installation. After this, we'll use the boots to secure our various fittings, the inlets and the outlets in the tank well. So we'll get back to you in a little bit and give you a little more information. All right, so now when you're sealing the edges, what you do is you just fold that top layer back a little bit, and you go ahead and lay your glue on both the outside and the inside. You let them dry for a few minutes, fold them back over, put some pressure on there, seal up perfect for you. Okay, the inlets and the outlets on the tank, they're going to happen through a boot like this. We'll ship you these boots. It comes in 4-inch, 6-inch, and 8-inch. This happens to be a 4-inch boot, but basically it's a piece of PVC, and it's got a tube through it. What we'll do is we'll stick your 4-inch, 6-inch, whichever size pipe you have. You slide it in there. You'll push it in until it's good and tight. And then we're going to carve the end off. We're going to put a hose clamp around it, and then when it sits on the tank, we're going to seal this whole edge to the tank. So the tank remains watertight.
This video shows the detailing how to fix all accessories.
All right, we got about 6 hours into it now. We've got the liners all wrapped around. We're wrapping the geotech around the liner. We're going to go ahead and secure that. We're going to go and backfill it. And as we backfill it, we're going to go ahead and pack down all that dirt around the tank so it holds the tank together. And then when we get up about 12 inches above, we're going to go ahead and lay our geogrid down. Now, your system might not need the geogrid, but in this case, we're going to make it H20 loading. So we're going to go ahead and add that on top of it. Now, here's one of our inlet and outlets. Okay, this happens to be a 4-inch inlet. And this is where we're going to bring the water in. It's tied into that boot below, and then it's also got like a stainless steel hose clamp around it that keeps it sealed.
The next component is delivery system. It is a normal piping system that conveys the stored rainwater till the point of end use. Then next component is ground recharge system. There are many artificial recharge systems available for use. One is artificial recharge projects are site specific. And even replenishing of the techniques in similar areas are to be based on the local hydrological and hydrological environment. The first step in planning the project is to demarcate the area for implementation of recharge scheme. The project can be implemented systematically by adopting hydrological units like watershed or micro watersheds for implementation. However, localized schemes may also be taken up to augment groundwater resources. Artificial recharge techniques, a wide spectrum of artificial recharge techniques is available. Techniques are used to recharge groundwater reservoir. Artificially recharged techniques can be broadly classified as given below. First is direct method, in which surface spreading techniques are used. One is runoff conservation structures like bench terracing, contour bunding, gully plugging, nala bunds, check dams, percolation ponds, then uh, flooding, ditch and furrows, recharge basins, and stream modification and augmentations. Second one is subsurface techniques, injection well, means recharge wells, gravity head recharge wells, dug wells, bore wells, tube wells are the for examples are there. Then recharge pits and shafts. We will see one by one. Then third option is combination technique. This includes combination of surface and subsurface techniques. Indirect methods, induced recharge from surface water sources, and another one is aquifer modification. In this case, bore blastings and hydrofractures are done. It is basically done when your subsurface is made up of solid igneous rock and have no fractures. So to create storage, you need fractures in the rock. Then groundwater conservation techniques. In addition to the techniques mentioned under A and B, groundwater conservation structures like structured dikes, means underground bandaras, and fracture sealing, cementitious techniques are also used to arrest subsurface flows. So one by one we will see. This is a bench terracing. We can see that mild slope has been segregated, or bunds are created on the terraces, so that water will be accumulated in this bunds, and it will percolate through the soil. So flow of runoff is avoided. Similarly, contour bunding is similar pattern. Then gully plugs, the natural stormwater gullies which are formed are by using natural stone soil. The bunds are created, which increases the time available for percolation. Then similarly, nalas are plugged so that on the upper side of nala, water will be stored for a long time, and percolation will happen, and subsurface will be recharged. Check dams are created, then percolation ponds. You can see the flooding. One channel is created at the higher elevation of ground, and from that canal, water is allowed to be get flooded over the ground, and it is then collected in the return canal at the lower elevation, and again left in the stream. Same fashion, ditch and furrows are created, which are the then again these canals are bifurcated in the ditches, and furrows are created, and more flooding area has been created. Similarly, recharge basins are created, and water is allowed to stand in these basins, so that more time is available for recharging the underground strata. In some areas, underground flow is present, but at the upper localities. In such areas, dike can be created. When this dike is created, the water behind this dike is underground structure, is means under the water table here rises up, and afterward it will flow through over the dike and move forward. The area behind this dike will get a groundwater table at the higher level. Then injection wells are there. In these wells are plugged at a proper depth, and water is pumped into it with a higher pressure to recharge the underground table. These all things are decided based on the topography and subsurface stratification. Similarly, the gravity head recharge wells are there, which is in general use. Water is stored in the tank, and overflow is allowed to be discharged in a borewell. In this borewell, the gravity head acts, but this water should be pre-filtered. Whenever we are directly using the water to inject in a borewell or subsurface, it should be filtered water. It is mandatory. Similarly, trenches are made. Over these trenches, the water is flowing and it is percolating through the trench, and maximum area is made available for percolation. These are some methods for trenches also. This is the percolation trench with percolation bore wells. This has been given in the, it is recommended in the National Building Code 2005. Here we can see that the rainwater comes here, then it gets filtrated, and then through these sieves it enters in the borewell and recharge the borewells. These sieves are so readily available in the market. I have some images in further slides. The same module has been improved in National Building Code 2016, and more detailing has been given. In this detailing, we can see that there is one bar screen here, then it is silting basin is there, then it is passed to the well, and well is also having vent pipes and another thing. So this drawing is giving more detailing than the previous one. So for ground recharge, there are also ready-made structures are available. So this is one of the Furat named precast model, which is also available for use. The technique they have used is there are two models they are have proposed. One is sand filtration module, which is advised for the roof top rainwater harvesting, and if we are using a surface runoff, then additional horizontal filtration module is also recommended. We can see the at different levels the detailed components, but it is more clear when we can see the video. So this shows the installation of this ready-made Furat percolation well. Surface water is collected here, then it passes through the side walls. These units needs also maintenance every 2 to 3 after 2 to 3 years. We can see this slide video also, but it will move forward so that we can reach up. It is not allowing to skip. Again, it is. Madam, it is visible.
Yes, sir, it is visible.
So for any artificial recharge, we need some components. Likewise, what I have already indicated that in NBC 2005, they have shown some sieves to be used. This is one of the sieve, V-wire well screen. This is basically used. V-wire is having a groove which is more on the inner side. So whenever particle skips from the sieve, it doesn't is remaining there. It goes inside. So whatever the size of your sieve is there, any particle lesser than that doesn't get clogged there. So it is also called as a non-clogging sieves. These are available in different sizes, but in general, ready-made are available at 0.75 mm slots and having the height of 0.5 meter, dia of 150 mm. As I have told, this doesn't get clogs and available in the SS. This basically reduce our efforts for maintaining the bore wells. You can see the representation how it can be used, but in this presentation they have shown that it can be directly used for the bore wells, but it is recommended that proper filter media should be there. Then another type of screen is available in the market, which are having two concentric V-wire screens, and internal area is filled with the gravels. So we can see that these sieves are the replacement to. I will show you this all structure which is having a filter here, then V-wire filter here, all can be bypassed by this alone sieve, and directly in the tank you can fit this sieve, which is also having filter gravels, filter media, and V-wire. So our area of filter is very much reduced, and also these are more maintainable. These are available in 6-inch and 12-inch, 8-inch and 16-inch combination, 10-inch and 23, and of the different heights, and their flow rates are ranging from the 7,200 liters per hour to 2,16,000 liters per hour. So this is giving us a edge over the space. Then in engineer AR Shiv Kumar has in his manual also shown that how a general readily available material can be used for increasing the percolation, where he has proposed that available plastic drums can be cut from the bottom and placed in series with connection in between them, and water will be stored in this tanks so that it can percolate for more time. So more efficiency can be achieved in the percolation. Similarly, RCC precast rings are available in the markets, which can be used for wells, infiltration wells. So the steps involved in this step, first we have to dig a well in the ground. Then at the bottom, one sand layer is given. Above that, these rings are installed. The area outside the rings is filled with boulders and rocks, which acts as a percolation media also for interface. The another is infiltration gallery for wells. In this case, the water is left at the top and is collected at in between, and this pipe is connected to the bore well or open well, so that this is filtered water can be utilized for recharging. Some actual photographs are also there, so that you can see this trench has first the trench has been made, then filter media is placed. Above that, one perforated pipe is placed, then again the filter media is kept, then plastic mesh, which is called as a filter grade geotext, is placed, and it is filled with a sand. And you can see that this, in this case, this pipe is connected to the bore well, so that filtered water will be available for recharging the well. Similarly, in the stormwater drain also, one can have a trench and it is filled with pebbles and boulders. Above that, one mesh is provided so that this impurities should not enter in the filter media, and we can increase the percolation in regular stormwater drains also. If we are providing a roads, road water can be first enter in the percolation trench, and percolation trench can overflow to the stormwater drain. So this will also yield more water to the subsurface area. Another methods are we can use our open lands, parking lawns and other things with the grass pavers of different types, which will allow the rainwater directly to the percolate in underground subsurface. Some are the do's and don'ts. Don't store directly the rainwater without filtration in sumps. If we do that way, it will get contaminated and will not be utilizable. So this is don't, and this is we should use a filter. Then using a normal filter, we should not recharge the bore wells. In case of bore wells, we should use sand filters, and then recharge should be done. In open wells, yes, these are comparatively at the surface, and we can store this water in open wells and allow percolation through the soil. Storage options are also there. How we want to store. One is roof slab itself is acting as a storage. So whatever water is rainwater is accumulating over the roof is stored in the roof itself, providing some depression. Second option is if there are two levels of roofs. First topmost roof is water is collected at the first level, it is used, and whatever the next level roof water is there, it is allowed to go in stormwater drains or in sumps. Storage capacity. Water consumption is is throughout the year, and water availability for the rainwater is for limited period, restricted to number of rainy days in a year. Means normally in Mumbai we get rainwater for say 3 months or 4 months, but the rainy days are normally limited to 90 to 90 around the 90 days only. To make rainwater available in non-rainy days, storage device is needed. It is to be designed for its optimal capacity. Now in rainwater harvesting, storage device is the single most expensive component. So that if we are constructing any rainwater harvesting unit, the costliest component is storage tank, and its size depends on the user and rainfall. Optimal size of storage device and cost effective method to store water are key issues for variable rainfall rainwater harvesting system. We can see that storage capacity depends on one, demand of water, availability of rainwater or rainwater potential, rainfall pattern, that is rainy days, variation in rainfall intensity. If your rainfall sometimes it is very less and another time it is very intensive, then your tank capacity will increase. If your rainfall is uniform, then tank capacity will not increase abruptly. Then how much funds are available for constructing the tank, material of construction, this all affects the storage capacity. We can see two examples. One is bungalow and another is high-rise building. Then we can see that demand of water in bungalow will be low, whereas in high-rise building demand will be high. Availability of rainwater in bungalow with respect to the persons living inside bungalow, the roof area will be more, so rainwater available will be high. In the high-rise building, it will be low as the effective roof area will be less. Rainfall pattern, if rainy days are more, tank size will be less. Means if your rainfall is spread over the more days, your tank size can be reduced. Funding restrictions. Bungalow person is a individual person, so financially there may be a restriction. Funds may be limited. Whereas in high-rise building, even though water availability is less, but due to the many families, fund may not be an issue. Material of construction. Depending upon the material of construction, size of tank or type of tank will vary. If it is indirectly, if you are constructing underground tank with the RCC cement concrete, there is no limit of size. But if you decided to use a FRP and other things, in generally more than 20,000 liters ready-made tanks are not, underground tanks are not available. Quality of rainwater, quality of harvested rainwater. As a primary source is the purest form of water, rainwater harvesting not only solves the problem of non-availability of water, but also provides good quality of water. However, it is needed to take precautions to ensure that the water is non-polluted. Keep the roof or the water collection area clean before then drain off the rainwater collected in first few minutes. Store the collected rainwater in closed container, particularly away from the sunlight. The quality of water deteriorates in the presence of sunlight and air. Water can be kept clean over a period of 5 to 6 months in clean container stored in a closed area protected from sunlight. Now, quantity of rainwater can be harvested. The quantity of rainwater which can be harvested depends upon the annual rainfall, the area of plot means catchment area, and soil characteristics. The amount of water infiltrated into the soil varies with the condition of soil, surface, and the moisture content of the soil at the time of rainfall. The total amount of water infiltrated depends on infiltration opportunity time. Means if the water is allowed for percolation for more time, there will be more quantity which can percolate, which depends mainly on the slope of the land and field structures like contour bunds, terraces, and other structures which tends to hold the runoff. This is the last part of topography shall be known, contour plan shall be prepared, as well as subsoil strata shall be known. For example, bore log data. If subsoil data is not available, help can be taken from the general awareness from groundwater information booklets. It is available district wise, published by the Central Ground Water Board. Rainfall details: average annual rainfall, rainy days, maximum design hourly rainfall shall be known for subject area. This data is normally available with Indian Meteorological Department or shall be made available from the different publications of IMD. Data from local rain or weather station is preferred. hydrogeology, pattern of drains, well types, and water table in locality, location of potential aquifers, which can be used for recharge and extract. When we recharge the water, we definitely extract it also of sustainability of subsoil strata in that locality. Many times, this data is available with the local contractor, borewell contractors. Catchment area, depending upon extent of area, it shall be subdivided upon planned drainage system, rainwater collection and carrying system, gutters and downtakes pipes. Gutters and downtake shall be designed for maximum rainfall for design return period. As per CPHO manual, they give the recommendation that for different areas, class 1 cities and another, this drainage system shall be designed for class 1 cities for 5 years, and for other cities it is 2 years. If you are designing for these drainage systems are designed for the critical locations like airport, railways, etc., then these values are taken on the higher side, so that normally return period indicates that if we are considering that 5-year return period, then in general we can say in 5 years one occasion will take place where your stormwater drains will overflow. If we are considering 2 years return period, it indicates that alternate year your rainwater system, stormwater system will overflow or will be not enough. Stormwater drains section design suggestions by different authorities. As per IS 8835, it suggests to design surface drains for 5-year return period, considering 3-day splash to give economical design option. Means it says that you assume that continuously 3 days rain has occurred, and then you consider a 5-year return period hourly rainfall. So indirectly it indicates that whatever the rainfall is there, it is going to come in the drains. IRC SP 50 suggests to design surface drains for 2-year return period and says that occasional flooding shall be accepted against the cost of drains. Whenever you develop the drain, obviously money is required. So over that cost, you can compromise on the section. Whereas IRC SP 42, Indian Road Congress Special Publication 42, suggests that drain along the highways to be designed for 25 years return period, considering the property loss due to the flooding of roads and adjoining areas. So it all depends, drain design depends on the consideration of situation and cost of locality or land. For downtakes, means roof drain pipes. This table is available in the NBC 26, and it gives directly you the how much area one pipe can serve for hourly rainfall. We can see that diameter of pipe in this column. These are the hourly rainfalls and respective areas which it can serve. So we can say that for many years for Mumbai, we are considering that for 50-year return period, 100 mm hourly rainfall is there. But now for last rainfalls data, we are considering it as 127. So we can see here for 50-year return period, if we consider 100 mm pipe can serve 67.2 meters square roof area. Then comes the filters and first flush devices. Every online filter unit flow rate is given by the manufacturer. Accordingly, unit can be selected for particular downtakes. If sand filters are used, flow can be considered as 2 to 6 meter per hour. But CPHEO manual is giving 4.8 to 6 meter per hour for rapid sand filter and 0.2 meter per hour. It is very on the conservative side for slow sand filter. While selecting filtration system, type of rainwater contamination shall be considered. So CPHO manual is giving this data, which is readily available, that what type of contamination is there and what should we consider for filtration. The first one is sediments and floatables. Then we can provide sedimentation basin before filtration. Pesticides and herbicides. Consider that your water is coming from the cultivated irrigated land and it is sprinkled with the pesticide. Then or another features contaminants, then don't use such water for recharging. Use for similar work. Means again for spreading pesticides or herbicides, this water can be used as a medium. Organic materials used for recharge by flooding. Means you don't directly use it in wells or another things. If organic matter is present, you can spread this water over land and allow it to percolate. If water is containing the metals, don't use such water for recharge. Reuse for the similar works. Oil and grease and hydrocarbons. Provide oil and grease trap before filtration. Bacteria and viruses. Don't use such water for recharge. Isolate contamination source. Nitrates and phosphorus. Don't use such water for recharge. Isolate contamination sources. So we should always know that what quality of water we are trying to percolate. Now, storage tanks.
Sir, excuse me, sir. Actually,
Yes,
sorry to interrupt you. Actually, we have already exited the time for session 1. So can we wind up the session, sir?
Yes, madam. I will take only 5 minutes. Okay.
Okay, sir. Okay. Thank you, sir.
For storage, volume can be calculated for say 2 families. 2 persons are there. Person per family we have considered 5. So total persons will be 10. For flushing of 10 persons, we will need about 450 liters for a day, and we multiply it for a year, it will be 164 days. Now designer and owner has to decide how much storage they want, since storage needs money. So accordingly we can decide how much period we can store the water. Say average subject area rainfall is 1 meter. So for 50 rainy days, the average will be 20 mm per day. Considering this, some equations and values for percolation and plot areas having the grass, having surface areas are given in the CPWD rainwater harvesting manual. By using that, you can calculate how much potential is available. So in this case, we are having about 1,70,000 lakhs per annum. So it is potential is more than the what is yearly requirement. So it is all dependent upon the user how much water he want to store. Delivery system is same. There are ground recharge system different, which we have already seen. Okay, there are some facts about the water. The total water available on Earth is same for millions of years, out of which we can see that 2.5% is a fresh water. Out of 2.5%, 67% is entrapped in the glaciers, 30.1% is in the underground, and on the surface it is 1.2%. On surface, which is the water that out of 69% is in ice and permafrost, lakes and another 20.9%, and in atmosphere it is 3%, and in rivers and another things it is 0.26%. So all these things, if we see, the last value of water available for human use is only 0.0072% of total water available on the earth. So how much water we are having, water we can actually use, it is in the very minute fractions. Save water and take care of fresh water. Thank you. Madam?
Yes, sir.
It is over. Sorry for taking.
No, sir, no problem. No
time.
problem. Okay, sir. Thank you. We now invite questions from our participants. You can unmute yourself and ask question to our expert.
You can also give your questions to the organizers. They can communicate with me.
Okay, sir. Okay, no problem, sir.
Okay.
Okay, sir. Okay. So on behalf of Bharati Vidyapith Institute and all the participants, I would like to extend our sincere thanks to our distinguished speaker, Mr. Bagul, sir, for delivering such an informative session on rainwater harvesting. Yes.
Thank you, madam.
Your expertise have given us valuable understanding of this topic and also reminded us of our responsibility towards water conservation. The practical insight and example have left a lasting impression on all of us. Thank you for taking the time to be with us and for sharing your valuable knowledge. We truly appreciate your contribution to this important discussion. Thank you, sir. Thank you so much. With this, we conclude today's first session, and I request all the participants to be in the meeting as our next session will be starting in few minutes.
Thank you, madam.
Okay, thank you.
Can I leave?
Yes, sir, no problem.
Yes, thank you, madam.
Thank you, sir. Supriya, ma'am. Supriya, ma'am.
Hello.
Haan, ma'am. Ma'am, we can start.
We will now begin the second session. Hello. Hello.
Yes, ma'am, you are audible.
Hello.
Yes, ma'am, you are audible.
Okay. Good evening, everyone. We will now begin the second session of ATAL FDP. For this session, we are privileged to welcome Sri Vaibhav Badgujar sir, a proud alumnus of DMC and a dedicated professional currently serving in the Public Works Department, Government of Maharashtra, with over 3 years of experience in the construction, project planning, and innovative technologies. Vaibhav sir also cleared competitive exams. Beyond these professional achievements, he is a passionate mentor guiding the students in preparing for government jobs and international exams like GRE and TOEFL. Today, drawing on his rich experience, he will be speaking on the topic which very crucial to our urban future, that is urban infrastructure challenges, building smart, sustainable and resilient cities. I would warmly welcome you, sir, to deliver this session.
Yes, thank you. Am I audible, ma'am?
Yes, sir. Yes, sir. You're
Yeah. So first of all, thank you, Supriya ma'am, for this introduction. And I would like to thank Principal Tandon sir for arranging this session and letting us join and share our views.
Thank you.
Yes, sir. And I would like to thank Saili ma'am, Minu ma'am, and Vipul sir for coordinating and getting this presentations all smoothly. So I will start with the presentation. It is visible, right? The
yes,
presentation
sir.
is visible? Yeah, okay, okay.
Yes, yes, sir.
Good evening all, and also again, I would like to say that Happy Teachers Day to all the faculty members present. And starting with the urban infrastructure challenges. Today's discussion is about one of the most pressing issues of our time. That is the urban infrastructure challenges, the challenges that we face in our smart city development. And the word we hear that smart city, most of the people think like it is that IoT, some rocket technology, sensors, AI, like that. But the basic definition of a smart city is like to create a city which is eco-friendly, inclusive, and capable of handling future shocks. That is the population. As India is having a population of 145 crores. So, and it is said that about 70% of the population is going to live in the urban areas by 2050. So we need to maintain and plan accordingly our cities. So before moving to the challenges, I would like just I know that many of you must know that what is a smart city, but giving a little glimpse about it. So a smart city is a city which uses technology, data, and innovation to make life easier. So it also includes in the improving the quality of life, the efficiency of services, sustainability, and citizen participation. If we talk about the quality of life, I mean by smart healthcare, like AI-based health monitoring systems and telemedicines. And if you talk about efficiency of services, then we can say that a smart power supply, smart grids, prepaid meters, GPS-based waste management services, and then about sustainability, it is about the renewable energy sources and reducing pollution by using the electrical vehicles and like that. And if we talk about the there are the mobile apps for complaints, bill payments, service trackings, online dashboards for data transparency, etc. There. What are the key features of a smart which collect the street light, which help in the traffic and energy management. Smart mobility, like nowadays drones in the very picture, and GPS-based buses, electric buses are there. If you talk about the energy efficiency, the smart grid, as you can see, the smart grid are there, and renewable energy is being promoted. We can say about the gift city, Gujarat city, which
Hello.
has the solar.
Hello,
Yeah,
Vaibhav, sir. Hello.
yeah, yeah,
Sorry
yeah,
to interrupt, but
yeah.
can you please make it as a slideshow?
Slideshow, just a minute, just a minute.
Huh?
Just a minute.
Yes.
Just checking.
Yeah, okay, okay, sir. No problem.
This is okay? Hello? This is okay?
Okay, sir.
Yes, sir,
Okay.
it is okay.
Okay.
Okay. Okay. So I was talking about the Gift City, the solar rooftops that are being installed in the Gift City, Gujarat, as you can know. The e-governance, we can say that people can pay bills and register complaints, or which we can assess services online, and safety and security issues, like smart surveillance and emergency response systems, make cities safer. And now moving on to the main topic, that is the focus of this key focus, and the main thing of this topic is that developing a smart city uh, sounds little futuristic, attractive, like good words are there. But first are there are many hurdles in coming up in the development of the cities. First, we can see it is the technological hurdles. We are going to see some hurdles that I have mentioned here. There are the 5 hurdles. First is the technological hurdle. Smart cities are built on data, sensors, and digital platforms. But if systems cannot integrate and share information, then the whole model can collapse. So, for example, in Barcelona city, one of the earliest smart cities, we can say, different platforms like transport, energy, and waste were not connected in the beginning, which slowed down the process afterwards. In India too, cyber attacks on municipal servers were there, and Nagpur have raised a concern if this the path we are going is okay or not. Secondly, we can talk about the economic realities. This I consider for a developing country like India as a major hurdle in developing a smart city. Smart cities require enormous amounts of investment, billions of rupees, for smart roads and bridges, metros, and governance platforms, that is the IoT and renewable energy. But problem is, where will this money come from? Because and how long will get to use that money, that is the rate on investment. That is the how much can we can get out of it in less amount of time. So that is not fixed. And about the social equity, as the technology is going on increasing day by day, and many things are adding up, it is some many of the people that are in rural areas are left out of it. So it is important to bond both the people, rural and the urban people, along with them. So this is also a hurdle, we can say. Fourth is the environmental challenges. As we are getting developed and developing things, and making new developments and inventions, a lot of eco-friendly systems are out of a way. Delhi, for an example, is a smart city, remains, but still it remains one of the most polluted cities. True smartness lies in consistent, resistant, eco-friendly systems like solar power, waste recycling, and water conservation services. And then if we come to the governance gaps, even if there is a lot of development, but the changes that a smart city needs are very quick. Like one thing may come up, and then again next thing may come up soon. But then for that we need a proper flow of agreement between the many governments, like the Zilla Parishads, the Nagarpalikas, the our state governments and the central governments. They should work in not they should not work in silos. They should work together. So we'll see this hurdles one by one. First is the technological hurdles. Seamless integration and data flow. This is one of the toughest barrier for a smart city in technology integration. On one side, we have legacy infrastructures, that is the old sewage systems, outdated traffic networks, and traditional utilities. And on the other way, we have technologies like IoT sensors, AI-driven traffic control, and digital grids. These two often crash. Like they cannot be go in hand in hand until both of them are in same levels. Smart cities thrives on interconnected systems, transport utilities, communication, and governance. But in reality, most of our cities still operate with fragmented and outdated data and infrastructure also. We can see the real-time examples. I will explain some data, and then I will tell the examples that are going on in the world and also as well on in the India, our country. So if we see about Pune, which had introduced an ITMS, that is the Intelligent Traffic Management System. The challenge was the existing traffic lights. They were from 1990s, and they had to be upgraded to match the sensors. They were not sensor equipped, so they had to first change this all the street lights, and then they had to match it. So Pune had to replace over 500 signals, and each signal costed over 2.5 lakhs. So it was around 12.5 crore extra cost besides the ITMS software that they were going to use. And also about Barcelona city, their old wastewater treatment plants and the pipes that they were using, they did not have the pressure measuring, or the tubes, the pipelines were not equipped with that. So they had to change around 30 kilometer of the pipes. The 30 kilometer of pipes were nearly around 20% of the total project cost. So yes, so this data the technology shouldn't be adding, but the bridging gap between the old technology and the new technology should be covered up. And then going on to the data interoperability and standardization. The second issue is data interoperability and standardization. To truly unlock the power of smart cities, seamless integration, open standards should be there. The things that we make new, like pipes and etc. things, they should have open standards that one source can use the other source also. If you talk about the Bhopal smart city, like the India had introduced 100 smart cities mission in 2015. So Bhopal was in top 20 cities. So in 2018, it had installed it launched the ICCC, that is the Integrated Command and Control Center, a central hub to monitor traffic, waste management, water supply, and street lighting. So the problem which we faced, that the traffic signals where NTCIP followed, which had another protocol. The CCTV had ONVIF standards, and the smart water meters were like vendor specific. So all the three were different languages, and they could not go hand in hand. So Bhopal had to invest in a middleware that bringing all of them on a single platform. So they had to integrate. So they had integrated over 4,000 cameras, 20,000 street lights, that is the smart lights, over various environment and traffic sensors into the ICCC. And also the cost impact was like 40 crores. That was around 15% of the total. Now talking about the London Smart City. The London Smart City included transportation, air quality, and public safety housing. Such systems were there. In 2000s, different agency had stored in silos, but they came with a quick solution. That is the Barcelona had a London data storage. They had opened an open platform, and in that platform, all of the all of the apps can work side by side, and they can access the apps side by side. So moving ahead, rapid growth. Now this is the main thing that India is focusing. Rapid urbanization is placing an enormous strain in our cities. Millions of people like they migrate in cities like Mumbai, Delhi, and Bangalore, and such cities they create an outburst. They overcrowding, the traffic jams, waste disposal issues are seen. So the second part of the dilemma is inadequate digital labor. Like many of the people they migrate are not mainly technicians or IT professionals, or having good knowledge in digital knowledge. So a smart city cannot function without a reliable high-speed internet also, and real-time data connectivity. So and unfortunately, in our many places, there are we focus that network issues are there, and technology are not that strong. So without a strong digital foundation, technologies like smart waste bins that are installed, AI-driven traffic lights, or even emergency response systems like the ambulance and the medical facilities which are connected by AI. They don't work together, so it can create a good gap. So let's take an example about rapid urbanization of the Bengaluru city. Not only Bengaluru, but also many cities of India are facing this issue. Like 3-4 days ago, we saw a reel where Delhi, due to rains, Delhi was clogged, and there was a 6 hour traffic issue. 6 hours traffic. People were caught in the traffic. So if you talk about Bangalore, in last 20 years, it is said that the population has doubled. Like in 2005, the population was around 63 lakhs, and now it is around 144 lakhs. So this rapid growth has outpaced the city planning, lead to massive challenges. Like a 10-kilometer journey is taking 34 minutes. 34 minutes is around 4.5 kilometer per hour. That's slower than a bicycle. So yes, and people are losing 117 hours annually. It is not only just the human time that is lost, but it is also about the fuel, and we can say that man hours also. Yeah. And then moving on, uh, connectivity gaps undermining which undermines the smart city potential. Thinking about the IoT devices, smart meters, real-time surveillance, traffic management, healthcare alerts, all depend on strong and the uninterrupted connectivity. Where the internet is weak, these systems either fail or do not launch. For example, an emergency response system is there. It cannot function effectively if the network lags or breaks. We'll talk about the insufficient internet connectivity examples in the next slides, and also the gaps in data in the broadband network shouldn't be there. After critical functions like emergency response, the real-time surveillance is also important. As a result, the community and also the communities are left out of the advantages of a smart city if we see these issues which go on for a long time. And then we'll see about the connectivity examples that are there, which the smart city heavily rely on the continuous data flow, sensors, camera, and meters. But without this internet connectivity, these devices either fail or operate below the potential. We will take about the Indian example, just to say. We'll talk about the Varanasi smart city. The Varanasi Smart City mission deployed CCTV surveillance, smart traffic lights, and waste management sensors. The problem, we can say, was inconsistent 4G fibers, and especially in the old cities with narrow lanes. Which was like about 20% of the CCTVs they had planned, like about from the 5,000 CCTVs, like 20% of the CCTVs weren't able to operate. So downtime was 1,000 cameras. So it was around 15 crore of infrastructure which was standing without being used. And another was like in Nairobi, Kenya, the Konza Smart City, and it was aimed. It was also the Silicon Savannah, which was at IoT enabled services. But like the Nairobi, Kenya city had smart parking and waste management systems, but it failed because the data penetration, the broadband connectivity was only 42%. So the 12 million loss we can see, the Kenya had to suffer for the just the standing infrastructure wasn't used. So in short, without fixing the digital backbone, the smart city potentials just remains on paper. It isn't practically put on use. And this is the another example where we can see a smart traffic management system, that is the STMS, that requires, for example, we can assume that a city that can require 1,000 IoT sensors, and normally which use a 0.5 Mbps speed, means the system needs a total 500 Mbps of reliable connectivity. But nowadays, if we consider in India, only 250 Mbps speed is we can rely that which is available. That means only 50% of the sensors will be actually working. So like it will be a city can suffer an economic loss of around 50-60 lakhs if we calculate every month from the wasted fuel and man hours. Though it is not able to calculate practically, but an average that can be calculated. So for technological things, we can say that here are the five, steps that we can say that holistic planning can be done. A city should be planned before properly, not a haphazard city. Like Navi Mumbai is a good planned city. Like Indore, Navi Mumbai is a good planned city. A smart city is not just installing technology, but it is building a good technology and technology, economy, and society environment. All these should work together. If we talk about the public-private partnership, a city cannot make or raise all the amount that is needed for a smart city alone. So public-private partnership, which a government can fund and the private people can put their proper knowledge and workforce in that, can be helpful. Also, human-centric design. The technology nowadays which is developing should not focus only on the tech savvy people. It should not leave behind the old people uh, which will create a problem for them to handle the new technology. So it should be user friendly. Pilots, adaptive governance. Yes, just like I said, the governance should be easy. The cities change fast, and laws and policies must be adapted quickly. Departments should also work together, and should rules should be little flexible in this case. For example, if a new parking system is introduced, the government must quickly adjust regulations to allow e-payments or e-billing or digital permits without any problems, yeah, or any bureaucratic delays. And if we talk about the pilot and the scale approach, like starting from a small town or a small place or a small area, we should we should not plan a whole city at once. We should go from bottom to a big area. So that's what we can say about the technology things. Now we'll talk about some other hurdles that are come in our way during for the technological things. For is the digital exclusion in the affordable housing. For example, many low-income areas don't even have reliable electricity or internet. These basic residents cannot use smart devices or online healthcare, e-learning services. Some resettlement colonies in Delhi still struggle with Wi-Fi and proper utilities. Same is with the Dharavi. I will come to that Dharavi part in some next slides. Also, the fragmented urban systems and public resistance. In many cities, cities like transport, electricity, they don't talk to each other. What do you mean by talk to each other? Like the technology work, the transport, a different department is handling the transport. Water, a different department is working in. So they don't work together. They work in silos. Also, the absence of comprehensive master plans. So talking about the master plans, our city plans are outdated, like they were prepared 20 years ago, around 20 years ago. So many cities still follow the outdated planning. So these don't include the space for modern needs like the metro networks, smart grids, or the EV charging. For example, if we take about the Bengalore's rapid growth, which has outpaced its city plans, causing traffic chaos and infrastructure strain too. Retrofitting challenges. Now we'll say that retrofitting challenges is also good, also a major issue that we'll be facing. Like we have to, so smart solution often add to the old cities with narrow roads, aging sewage, and old power lines. Upgrading the old setup is costly. Like we'll have to reach a level first, and then we'll have to introduce the technology, the upgraded technology. Like we can say that retrofitting underground cabling that is going in Mumbai's overcrowded neighborhood is far more difficult than building it in new planned cities like Navi Mumbai, just like I mentioned. Data management and cyber security. Now, if we see on a top level, that is the not the small cities, but if we consider the whole city, uh, smart cities generate a massive amount of data through cameras, sensor, and apps, and this data must be real time in order to help us in making things work. So, so the challenge is not just storing it, but analyzing it and also protecting it from hackers also. For example, in 2020, cyber attacks on Indian city, which exposed citizen details, which was concerning, and this causes mistrust in our citizens. Skill gaps and workforce readiness also. Running a smart city requires skilled engineers and data analysts, but many local bodies and trained professionals are not. But our government usually lack such trained professionals. We'll come to digital exclusion and affordable housing. Uh, And this first is the infrastructure deficiency. That is the housing that are planned. The government yojnas are there. They are planned well. There's no doubt in it. They are planned very well, but they just provide housing. And main issue is that they do not plan on the internet connectivity and reliable internet, which is the main thing in developing a smart city. Secondly, there is an urban planning disconnect. That is the housing scheme often focus only on the providing physical shelter that I said. For example, this yojana, this results only like digital. They just cut off digitally people are not able to use their services like DigiLocker, telemedicine apps, or online job portals. So they're cut off. And also, I was just like I was saying, Dharavi's project. This is Dharavi usually. So this is the world's largest slum, and this the planning of physical housing units, that is around 300 to 350 square feet units going on in place. But the neglected thing was that broadband or the community Wi-Fi access, which was not planned in this. So as to for a city to be truly smart, affordable housing must not provide just walls and roof, but it also should provide digital access and connectivity. Moving ahead, fragmented and urban systems and public resistance. Fragmented systems, if we talk about this, the transport, power, waste management, and water supply. These all services currently in India work in silos and are incompatible with the technologies. This makes it extremely difficult to integrate data across systems. This results in the duplication, inefficiency, or also miscommunications in the various departments about who the data will be, who will take in charge of the data that is going on. And also about the public resistance. Many residents do not understand the purpose and benefits of smart solutions, like the water meters that we'll be discussing ahead. And the privacy concerns are also there, like hacking, cyber security are there. So unless the people trust and accept smart solutions, even the best technology is going to fail. We'll see a case study. Uh, in 2025, this is the recent news. The Pune city had implemented smart water meters across household, but instead of smooth adoption, they faced massive public resistance. The protest broke out regarding this. The reason just was due to low awareness. People were not sure about whether it will be costly, the privacy, or whether these meters will be really beneficial. Normally, people have a mindset like the way they will work in the conventional way. So this was the resistance that they faced. But now this issue has been cleared, I guess. And we'll talk about this privacy concerns, which the Hyderabad city had faced. The city in 2022, January 2022, had tried to introduce AI surveillance for policy. It faced opposition from citizen and activists. The matter even went to the High Court through a PIL, that is the litigation, and people face the use of their recordings, whether the government will track them and will use for other purposes. A part of 600 crore investment was there, which was unutilized, and we can say that they were planning for the crime solving efficiency, which was dropped by 10%, and also it led to a economic loss of 200 to 300 annually. It was a socio-economic loss, we can say, not really measurable, but it was a kind of loss. We'll talk about master plans. Like we said, outdated city development plans were there. Most of the Indian cities were following an old plan that was 10 to 20 years ago. At that time, nobody must have thought about the digital infrastructure. A plan made in 2005 might not only talk about buildings, just flyovers or housing. But now, today, there's a need of Wi-Fi enability services, solar power street lights, and smart traffic management services. Also, face the regulatory hurdles. We will talk about the regulatory hurdles in the last part. Also, the retrofitting and the public resistance. Upgrading existing infrastructure requires a huge investment, and the process is disruptive. The roads get blocked and services are interrupted, and the noise levels increase. This creates a citizen fatigue that we say, and also the aging infra. With the infra, we have to update it. We'll talk about this high cost, which was about the Bangalore city, that is the Whitefield Metro integration. This metro part required digging up existing sewer, water lines, and power lines. An estimated 800 crore cost was just added for relocating the underground utilities. This cost was nearly 20% of the total corridor budget. And if we talk about the blocked roads, the Pune Smart City had roadworks and around 2 years of closures. Citizens protested for it. Water pipelines were busted, and the traffic issues were there just because of the road closures. If we talk about the mistrust and the privacy, the people having the citizens fear overreach and misuse of data, and also about the compatibility issues, because the older systems that was not completely modern, had modern sensors equipped and platform. If we take an example of the Mumbai flooding, outdated drainage systems, block water meters and management initiatives, which make it difficult to integrate the flood warming sensors. If we talk about the data management, we can compare it with Singapore. The Singapore city is the smart city in Singapore is running way ahead of the Indian cities. On one side, there is the data overload. And if we talk about the data overload, the IoT devices generate so much information that the cities struggle to process it effectively. Our small offices even requires a big AC occupied server room. So we can imagine about the cities, smart cities, which will be collecting so much of a data. Like the Bhopal will be collecting 1.5 TB data per day, and the Singapore is currently collecting 1.5 petabytes per month. And also due to data overload, there is 50 to 20 minute delay alerts, which is like if an ambulance is there and a delay, a response is, we want a response. So 15-20 minute delay will really affect the communication. And also about the Singapore smart city, they had developed a national sensor platform with advanced AI management, with AI technology and the ML services. And this with the use of this, they just had the data transfer of efficiency of 15 minutes to 5 minutes, and which saved a whopping $100 million yearly. So like we'll take some time to reach that level, but it will be in the process. And the cyber security, if you talk about the cyber security, the things are even riskier. The interconnected system means a single cyber attack can paralyze multiple services. For example, Delhi has already raised concern about platform security, and Chandigarh had faced citizen data breaches under its smart city program. We can learn about the Chandigarh smart city that had caused the cybersecurity issues by September 22 to 2022. The city had registered 114 crime FIRs regarding the cyber fraud. That the Aadhaar link KYC had been their Aadhaar link KYC had been spread. So on the global side also, the Ukraine had power grid hacked by cyber security was hacked in 2015. If we talk about the skill gaps and the workforce readiness, we don't have the skills that are required for the AI technology. If we consider about the government services, many are yet to get into the government services. Like they take civil engineers and electrical engineers also in the and also the mechanical engineers. But rather than we do not see any recruitments for the cyber securities or such positions. So, which really should be taken into consideration. The security frameworks and smart meters and traffic control platforms can then only work effectively. And also, not only the smart cities required to work with digital dashboard sensors and AI tools, but also the continuous municipal staff requires upskilling to manage and operate new smart systems effectively. Just because the technology keeps on changing day by day. So now we'll have to train our workforce, our Indian people to match that level. Now we'll move on to the economic realities of a smart city. One of the biggest hurdles for a smart city is funding. We'll talk about the high cost that causes a major parameter and hurdle in planning a smart city. Building a smart city is very expensive. It is not making just a road or a park. It is like a building with entire city with modern technology, roads and smart sensors, digital systems, Wi-Fi and green infrastructures. So for that, we need carefully planning. Also, a strong economy is needed. To keep a smart city alive, the city must be financially stable. If the local government struggles with the basic expenses like water supply and garbage collection, then it becomes very hard to maintain costly smart city systems. Also, the funding struggles. Many developing countries, also about we can talk about India, cannot afford everything. The private investors often hesitate because the returns are because the returns are not that quickly. Like in normally we can get the returns of a normal project in 3 to 5 years, but in smart city, in case of smart city, it takes around 10 to 20 years, we can say, for the returns. The running costs, the maintenance doesn't stop. The CCTV cameras, data centers constantly have to be upgraded. Also, the slow progresses. Many smart city can face delays or even cancellations because the change in the we can say that the changing in the politics or such events. Now, talking about the high initial investments and the funding barriers. Big upfront, talking about some big upfront costs. Unlike conventional urban projects, where costs are incremental, smart city projects require simultaneously deployment of multiple advanced systems, such as the IoT centers and GIS platforms. Also, the getting the funding is not easy. For that, we can use the public-private partnerships, and but also the private ventures do not easily come in picture because of the late investments return. And also they are uncertain because of the changing politics, just like I mentioned. Also the bureaucratic hurdles, the red tape slows down the implementations, the land acquisitions, multiple government clearances are there, interdepartment coordinations are needed, but normally these hurdles can make the project delay. If we talk about the Bhopal smart city here, the total project cost was around 3,000 crore for the smart city. But out of this government, or out of the government could provide only 1,000 crores. and the remaining had to be funded out of the public-private partnership models and the municipal bonds. But the municipal bonds could offer only 175 crores. So the funding issue had been seen in the Bhopal city case. Now coming to the long payback period, just as I mentioned, typically private ones or also or the private ventures, they prefer fast returns, but the smart city projects may take 10 to 15 years or also 20 years. So and also the measuring of the ROI is complex. We'll take these examples in the Pune Smart Lightning project. The replacement of 2 lakh streetlights and smart LED was required, and the investment was 500 crores. The annual savings were electricity plus maintenance. They said it was 70 crore, but the payback period was, if we calculate, it was like 502 divided by 70. That will come around 7.1 years. So this benefits reduce crime and CO2 emissions, which are hard to monetize, adding to the ROI uncertainty. Also, the Barcelona smart city in Spain, the investment was 1.5 billion euros, and the total investment was that, but annual savings was 300 million euros. So the payback period was 5 years. Not all 300 million were direct cash inflows. Many benefits were intangible and like better air quality. So we cannot calculate in that. So it is uncertain and little bit difficult to calculate the ROIs. Here we will take some examples again. For the Bhopal city, the integrated command and control center in the investment was 500 crore, and the parking management fees was to the parking center was going to be developed. So the parking management fees that will be generated was 10 crore per year, and advertisement rentals suppose were 5 crore per year. So the indirect benefits which were hard to quantify, which are cannot be quantified, were reduced crime signals, so CCTV analytics, faster emergency response systems, and traffic decongestion, which led to the fuel savings. And if we talk about the Amsterdam city, 200 million euros were invested in intelligent traffic management services, which the aim were to reduce in traffic fines, but indirect benefits which were not able to calculate were 10% reduction in the congestion, which saved $100 million per year, and lower CO2 emissions, which indirectly contributed to EU carbon credits. And talking about the economic disparities and equity issues, firstly, there's the issue of unequal access. Smart services like the intelligent traffic management and Wi-Fi hotspot leave poor people behind. This creates a digital divide where citizens who already have good resources get better facilities, whereas the marginalized person remain excluded. Secondly, there is issue of gentrification where the smart cities improve infrastructure and property values often rise. This benefits the developers and the wealthy residents, but it displaces the lower income group, which have to shift to another part. In Mumbai, smart technology focused on Kolaba and Marine Drive, while Dharavi and Govandi are still being left behind, and they do not have such CCTV inclusions in their planning. We'll talk about the ongoing maintenance and financial sustainability and also the budget. Smart city projects don't end once the infrastructure is installed. They demand continuous and financial commitment for the upgradation, maintenance, and operation costs. One of the major factor is operational cost, we can say, the software updates, the hardware maintenance, and the cyber security, the trained technical staff. Without this, the systems quickly become outdated and are vulnerable. Another critical issue is that budget constraint. The city administration already stretched the resources to deliver basic healthcare services, water and sanitations. This leaves a little financial room for the development. So these issues should be addressed. Talking about the Pune Smart City Wi-Fi project. So, but the Pune had launched over 200 Wi-Fi hotspots as a part of its program. While the project started successfully, it became difficult. What was the challenges was the bandwidth charges, network security, and the technical staff, which required continuous spending. So the revenue from the advertisements and data partnership was far lower. So the outcome was that many hotspots became non-functional within 2 3 years. And if you talk about the Sondgo Smart City, which is in South Korea, it was also the one of the most advanced global cities with extensive IoT based. But the recurring costs were this city had to spend millions annually on the system upgrade, server maintenance, and cyber security. And the challenge was that despite of the high infrastructure, the residents had to pay higher service charges as compared to other cities. So initial investment was only half the challenge. The city had to require a steady financial model. So this was the problem faced by these two cities. Now comes the workforce and the business related things which were getting affected. Job displacement. Now, if we say about India, this is the major issue. This picture I had once seen on the social media, where the job displacement, we can say that it was a major part which played. You can see the helicopter was taking a big role. The cameraman, his camera, so many people were getting jobs, but due to upcoming of this technology, drone technology, just a drone is enough to take the job of these all people. So this competition also the business competition, we can say that the large international companies usually win the contracts. This often leaves the small vendors and businessmen who can't compete at any level. When automation replace the workers, not only the laborers face unemployment challenges, but loss in the household income. We can also see that 2 crore drivers, which are on buses, taxis, or also the delivery partners who are there. So 2 crores, if a Tesla company or such companies who offer auto driving comes in the picture, so a lot of job unemployment will be seen. Similar happened with the Surat textile market, which the automated looms had replaced the traditional hand-operated looms. Around 40,000 workers were working there. And if we can even consider like 12,000 per month of their salary, the local economy of the Indian economy had to lose around 400 crore annually, which is a good amount, which reduced. Also, the Amazon Go stores, the cashless technology, which was introduced and which led to a single store which eliminated around 25 cashiers. And within 30 stores, it was said by 30 stores replaced 25 cashiers. So it was a good amount of a layoff that was seen, which led to the drop of 10 to 15% revenue drop, amount to millions in turnover. While the Amazon was profited, but the communities on a local level or a smaller level faced significant income and consumption losses. Now, if we talk about the market fluctuations and economic volatility, smart city projects depend a lot on the economic conditions of a country. If the economy is doing well, it is easier to get money for such people, for such projects. But if the economy is weak, which the things may get very difficult. For example, during the time of recession or slowdown, the government has less money because of taxes collections as they go down. At the same time, the private investors fear of and become cautious and do not directly invest in the smart cities. So yes, this happened in the Amravati smart city. Like the city had an estimated cost of 50,000 crore, but after the 2019 political change and economic slowdown, the private investment slowed dramatically. The state government already had been facing budgetary constraint, so they had to scale down the project. So this pays the economic thing plays a good role in the smart city development. And if we talk about the inflations and the rising costs, it is a bigger risk for a smart city project. Inflation means the prices that are going up. While smart city is getting planned, the budget might look affordable, but the inflation during this construction can rise as much as to too expensive as the originally planned city. If we talk about the examples, in India, the Pune Metro project, which was launched around 2016. The budget was around 11,420 crore, but it went to 15,400 crore. Like it is around 35% of escalations. This was just uh, because of the increasing cost of the material and inflation, and also the external dependencies. Many smart cities rely on that is the developing cities. Developing countries also having the smart cities cannot build only within the local funds, so they have to depend on the outside money in forms of grants, international loans, and partnerships. And if this creates a big challenge because external funding is not always stable. Sometimes it comes with the political conditions or changes depending on the priorities of donors or higher government authorities. This means that a project can suddenly lose or support or face delays if a funding is cut or redirected. So this is the challenge that the grant can face if the project is on loan. In short, we can say that relying too much on external funding makes a smart city uncertain and politically influenced and vulnerable to the delays. If we see about the Dholera project, Dholera Smart City project, this city, which was set like 3,000 crores was invested, but it remained unutilized due to the delayed public-private partnership. Also the funding that was the city was going to get by the foraging issues. If we talk about the takeaways, what we can plan out of it. If we say that the plan money matters smartly, we just can't depend on the government, and we just can't depend on the government or the outside issues. The city who has to get smart needs to plan their finances properly, like making household budget on a bigger scale. Apart from them, loan from government funds should also think of creative options like PPPs, like we said, growth for everyone and not for few, which should be our aim for the growth. When the smart city comes up, only few rich people get benefit, and the poor people and the families are left behind or even pushed below their income line. So to avoid this, the policy should make all the citizens and the new facilities are available for them too. Now we'll move on to the social challenges that come in our way. Social equity, bridging the digital divide. If we talk about the digital divide, not everyone has the same access of the same level of access to the technology. Some people have smartphone, fast internet, and know the knowledge to use them, while other people may do not have even do not have a smartphone. If the smart city are designed only on the digitally smart or the wealthy citizens, then the benefit will stay limited to that group only. So the inclusivity, that is, no one should be left out. For example, the senior citizens, women and children, they should be, and the rural immigrants, which are the economically weaker sections, or the also considering the person with the disabilities, should be app friendly. The platform must be designed to make them accessible to. Also, the citizen participation should be there. Listening to the people, their wants, their need is important. For example, a city might spend a lot of money in designing a fancy smart parking system, but the people in that area might be struggling with the water shortage issues or waste collection systems. So, which should be focused, and it should be focused. It is crucial that the people should be focused. That the people views should be focused. So coming up with the example, in India, Bhopal Smart City, the Bhopal had invested 300 crore in smart city missions, but the challenge with that, many low-income households in slums and cluster lacked access to smartphone itself. So 30% of the marginalized residents were not able to use the e-governance services that was dispersed by the government. Similar for the globally, if we talk about similar, it was for the Barcelona city. But now the Barcelona city, as they came to know about this issue, they opened up a platform named as Decidim Barcelona, which enabling over 40,000 residents to create policies and budget, ensuring inclusive development, taking their views in the taking their views in consideration. If we talk about the social challenges which are limited to the human element too, the people when the people heard a smart city, we often imagine like the CCTV cameras, Wi-Fi everywhere. But the truth is, a smart city is not about machines, as we like said. It is about the people and society. Lack of awareness we can see, like people do not know the benefits. Example, we say that if the city introduces an online tax payment systems, but the citizens do not know how to use it. They will either stand in long queues or at offices and avoid paying on time. Also, we're coming on to the cultural resist and distrust. The cultural resistance, which mentions that the conventional part, like people are comfortable with the traditional methods and they hesitate to adopt new ones. Old shopkeepers, for example, we can say that they may prefer using cash, even if the digital payments are safer and faster. Like even if we in the cities, we usually see that the shopkeepers are used to it, but the older shopkeepers who do not have that interactive thing with the app and the QR systems may find them difficult. Also, a distrust, that is the fear of misuse is there. We can say that the CCTV cameras that are installed, some citizens will worry if what if the government watches us all of the time? What if the footage that is captured is misused? So this will the people if the people believe that their privacy is at risk, they may protest, file case, or simply avoid using the system. Moving ahead, these are some examples that was seen that was seen during the Delhi CCTV and facial recognition project. Strong protests were seen by the NGOs and civil liberty groups. So what was the impact? The impact was that the project were delayed over 2 years, and the additional cost in maintenance and existence of the outdated systems were there, leading to extra manpower, system patching, and litigation costs, which were around 150 crore rupees. Also, we talking about the Toronto, Canada. A smart waterfront project was there by the Google Sidewalk Labs faced opposition. The citizens opposed to this project due to the data privacy fears. Impact was that even after 2 years of planning and investment, $50 million were just in the studies and design studies and the studies. The project was, after all, cancelled in 2020. So now, planning for the ensuring citizen engagement and inclusion. Citizen participation is important, like we discussed, and solving the real problems together should be there. A city may invest in building a cycling track, but if there is no safe parking stands for cycles, very few will use the cycles. Talking about the not in my backyardism. For example, when the government wants to set up solar farm near a village, residents may protest, worrying it will reduce their agricultural land. But seeing on a third party, if we say that government is setting a solar power farm, a third farmer will see that it is at a good project. But when it comes to him, he will worry about getting his agricultural land reduced. So this adaptability should be seen in the people which are going to contribute in the smart city. The community involvement and the closing gap awareness should be there. For example, a new mobile health clinic has been opened and may be equipped with digital patient records. But if these slum residents do not know that it exists, they will never use it. Outreach campaigns are needed to bring such services closer to them. Addressing the digital divide. One of the biggest challenges is the digital divide, that is the gap between the people who have access to the technology and who do not have. Many families who live in the poorer neighborhoods and informal settlements do not have smartphone computers or even stable internet. Some may have the phones but lack the knowledge to use them. So the digital divide should be built up by the bridging gaps. A city may access to the devices and the internet is the first step, and the equal distribution, not just giving the priority to the rich areas, should be avoided. Moving ahead, this is the example which is related to our slide we saw about the digital divide. In Chennai, the initial smart city deployments such as the digital payment kiosks and e-government portals had IoT-enabled traffic systems which only focused on the high-income areas. So studies revealed that only 40% of the residents in low-income neighborhoods could not access key smart services due to lack of devices or digital literacy. We'll see just an example due to lack of time, and we'll move ahead with the promoting public health and such issues. There was about this slide. I will just like to focus on these bars, where there was a research which mentioned that 75% of the people were concerned about a privacy. 60% of the cities lack clear policies about what a smart city is, and 90% of the people had a trust impact, where the people said that the trust is lost when the policies are too vague or complex. So these all the things that we should see about the designing a smart city. We'll see about the disaster preparedness and resilience. One of the most important responsibilities of a smart city is to keep the people safe during disasters, whether it's floods, cyclones, earthquakes, or even man-made emergencies. But technology will help. We assume that the technology will help in the disasters. It will give real-time alerts for us and evacuation planning. The resource optimization is there, and the recovery support is there. But the challenges what will be exist is like the if we talk about the system integration, if the meteorological department which ensures a cyclone warming, but the city's traffic app doesn't sync with it, then the evacuation planning will get delayed, which will hamper the process. If you talk about the citizen training and awareness, a community may have good flood warming services on their phones, but if people are not aware what to do when such warming comes, or do not if the people cannot analyze the services, they may just panic and ignore it, and the crucial time will be lost. Resource coordination. If we talk about the urban fires, sometimes two rescue teams reach the same spot while another affected area is left waiting. So we'll see what are the takeaways. So prioritizing the people first, like taking the trust and awareness of the people, bridging the divide. That is the rural urban population should be treated equally. Ensuring the transparency, why the data is collected, the CCTV data which is collected, which the people were not aware of. So if they will be knowing it, then they will be using it also. The clear policies will build trust and confidence in the people. It will focus the engagement of the people also. If the people plans, if a city plans e-bus routes without asking the commuters, the routes may end up underused. But with the local feedback, they can be optimized for the real demand. Also, the building resilience is important. The technology plus training will ensure the safety, survival, and recovery process. For example, if we take that the early warning system for landslide or storms save lives only when the citizens know how to respond the alerts. Moving ahead, we'll be left with the environmental issues and the regulatory issues. So we'll be talking about the pollution and the climate resilience. Air pollution is one of the most visible and the pressing issues nowadays. If we take about Delhi, the Delhi has installed real-time smart monitoring systems. to track the air quality. These stations provide data that can inform policies such as the traffic restrictions, shutting down during factories, or issuing public advisories. But the problem isn't about monitoring, it's about enforcing of emissions regulations, reduction of crop burning in nearby states, and shifting the low emission transport systems. So the scenario has Delhi has over 50 real-time air quality monitoring stations, which are generally generating continuous AQI data. Despite generating the data, the levels that are the 2.5 PM levels are frequently exceeded over the 300 microgram per meter cube in winter, which are above the WHO safe limits. Now this has impact over estimated over 15,000 to 2,000 crore annually due to pollution-related diseases, which is not measurable on a scale, but yes. We'll talk about the resource management. One of the major issues, struggles that a city faces is that managing limited resources like the water and the energy. If we talk about the Chennai, severe water crisis have been there. Also about the Bangalore, we can see it in the news. It is almost reached to very lower levels. To fix this, cities should be turned smart water systems, but there are serious challenges are there that old infrastructure is there, which we saw about the Barcelona. They had 30 kilometers of old pipeline. So such old things have to be replaced. If we talk about the ecology, the Indian, if we'll just jump up to the example about the Bengals, about the Bangalore city, which in the Bangalore city and the IT and the IoT infrastructure scenario, the rapid development of IoT sensors, the CCTV and the server systems in public spaces and traffic management were seen. An estimated of around 5,000 ton of e-waste had been generated annually from the obsolete devices and sensors. So what was the impact? The carbon footprint from the energy usage and usage of the servers and devices were around said to be around 10,000 tons of CO2 emissions per year. Now, seeing about the green spaces, you all must have heard about the Hyderabad forest news about this Gachibowli forest destruction that went for the IT space park. But then many protesters came and then they cancelled. The Supreme Court stopped the destruction of the forest. So these are the habitat loss, which is the major concern of this increasing smart cities and the technologies, replacing the forest, lakes, and farmlands, which pushes the local plants and animals out of the habitat and natural homes is seen, and which will create an irreversible damage, as we see. If we compare about the if we study about the Mumbai's RA forest, which was very controversy and highlighted also for many years. So now moving ahead, we'll see the key steps. Holistic integration should be there. That is, the policies and smart technologies the technology, policy, and the ecology must work together. So the government should not be working in different silos. Life cycle thinking, evaluating the environmental impact of smart technologies from production to disposal is important. Adaptive governance, which we'll be seeing upfront, and the community engagement. Citizens must be partners in sustainability, which will help in energy conservation, protecting green spaces as well. Moving on to the regulatory issues, which is the last session or the last topic of our challenges that we faced making the policies. In India, smart cities are not about installing sensors or creating apps. They must just comply with existing municipal laws. So here, some of the laws are there. The policy names are there. There were a number of laws, but some of the laws were mentioned, like Digital Personal Data Protection Act. It was said that it will protect the data, but it was not for all the government agencies, which were partly exempted. This could lead to the misuse of the mistrust. This could cause mistrust in the public. Also, the Information Technology Act, which was launched in 2000. Now, this act, there has been 20, after this act, in 25 years. Now you can see that there has been only in the 2000s only basic model of the mobile phones were available, but now the technology has gone up to a different level. So it regulated cybercrime and digital transactions, but limited to IoT coverage. Also, the smart cities guidelines, roadmap for smart cities were there, but limited privacy and consent rules were seen. The regulatory maze, we can see interagency coordination. Interagency coordination in Mumbai. We'll take the example of a smart pole in Mumbai. Like integrated smart poles were to be set up in Mumbai. The Wi-Fi, CCTV surveillance, and public charging stations and environmental sensors were to be installed. However, the project got delayed because multiple agencies such as the BMC, MTNL, and the MMRDA had overlapping jurisdiction over the course. Each agency required several approvals, and there was no central coordination, which caused the confusion and repeated revisions of the projects. Talking about the regulatory frameworks, a significant challenge in a smart city is the absence of adaptive regulatory frameworks. The private investors and the businessmen often hesitate to participate when the rules are unclear, vague, or outdated. Let's consider a real example again from Bangalore, where certain startups proposed AI-based traffic management systems to optimize the traffic flow, reduce congestion, and improve road safety. However, the pilot faced significant hurdles. The lack of clarity on data ownership, who the data will be owned, the traffic data collected from the cameras and sensors, who will own, the unclear rules of the integration with the Bangalore traffic management and the police systems, making it difficult to operate the AI recommendations. And yes, talking about the some challenges, that lack of the updated legal structures, like we said that many cities lack comprehensive legal frameworks, data governance, and IoT standards, and the privacy protection as well. And also existing laws that should be that were not developed for the new smart technologies. Hyderabad, the complex rules have hampered the city implementations. The Hyderabad city roads were constructed, and after that, the city had to been dug up for the laying of sewers or any cables. Such thing has happened in the Hyderabad. These are the coordination challenges. For example, in Ahmedabad Smart City project, the smart city missions were delayed because of the road cities and utilities agency didn't coordinate, just as the Hyderabad example we saw. And also in the Pune's delay in the release of central government funds happened because the state government and the PMC disagreed upon the project prioritization, and this slowed the project, like the smart lights, smart traffic lights, and e-bus integration. Now coming on to the bureaucracy and the data governance. This topic we have discussed, the privacy concerns, the data ownership ambiguity about who the data will be owned, whether a BMC or the MMIDA, like this, and also the red tape delays that, like the proper insignificant delays due to the land acquisitions and the government policies have been seen. So building trust and engagement and accountability should be there. Smart cities do not just fail because of the technology. They will fail when the people do not have trust in them. The public resistance, we'll just take an example of the Mumbai CCTV project. The resistance was there because when the CCTV-based traffic fines were introduced, so people did not have clear ideas about how the fines will be issued. Well, they were ambiguous whether the fines will be fair or unfair. So this created a public resistance on the in their part. Also, the foster stakeholder engagement. We should involve the citizens, businessmen, and the local organization to sit on a table to decide about the a project or a city that has been going many changes. For example, in Pune, authorities use digital engagement platforms and approach were built more and this participatory approach build more transparency and acceptancy. Also, we'll see about the transparency. The clear communication on goals, risks, and outcome is vital to maintain the legitimacy and the sustained public support. Building a smart city is not about just a technology. What I think is it's infrastructural policy. It is about creating a future where innovation, inclusiveness, sustainability, and also trust, people's trust walk hand in hand. The challenges are many: technological, social, economic, and regulatory. But none of them are avoidable if we plan wisely, act collectively, and keep people at the center of the every decision that the government is going to take. A truly smart city is not just one filled with sensors and app, but the one which the citizen feels safe to use and empowered and connected and cared for. It is said that the smart cities are not built by machines or policies alone. They are built by people and for the people. And by this, I would like to end my session. Thank you all. Now, I would like ma'am to take over if it's done.
Thank you, sir. Thank you so much. We are now opening the floor for the questions from the participants. If
Yes,
you have
please.
any doubts, then address your queries to our experts. Any doubts? Ask the queries to our expert.
We will be touch with Supriya ma'am in any case if any data or any study is comprehensive studies related or required for this. So we'll be in touch with ma'am.
Yes, sir. Yes, sir. I think there are no doubts, sir.
Okay.
Okay. We will now conclude today's question answer session. So on behalf of BVIT and all the participants, I take this opportunity to express our sincere gratitude Shri Vaibhav Badgujar sir for delivering such an insightful, engaging session with very nice and real examples. Your expertise and valuable insights have truly enlightened us and provided new perspectives that will benefit us in our academic and professional endeavors. Thank you very much, sir.
Thank you, ma'am.
Okay. Okay. We have now concluded today's session. Tomorrow is the final day of our ATAL FDP program. So we encourage all of you to attend this such an interesting and knowledgeable session. Thank you, everyone. Thank you so much.
Thank you all.
Thank you, sir.